All right, we'll get started. Is everybody ready? Um, let's, when you get a chance, try to invite your teammates in so that we can do the exercises. It'd be good to have you guys practice on that as well. All right, welcome to class 11. Our quote of the day is actually from Ronald Reagan. One of the things he used to say is, still trust but verify, it's still play but cut the cards. It's still watch closely and don't be afraid to see what you see. And I love this quote in relationship to validation. And a lot of times you have to be not afraid with how the system will actually turn out, and that you will be always trying to accommodate your customers as you go forward, and your clients. All right, let's start. There we go. Class 11, was the right system built? Can everybody hear me? Just unmute and say, yeah, I hear you. Just
Yes, sir.
okay, good. Just to making sure that everything is good. What I want to try to do is get you to understand kind of the various set of actions that are required in order to make sure a system of interest is compliant with whatever purpose or function it was built for. So that's why we're kind of coming together here. So this is one of the pre-ultimate, I guess, lecture here. We only have one more to go, and then the TRR and the final, and we're done, which I'm sure you guys would all be happy for. Hopefully you've turned in hardware number 5, homework number 5. Homework number 4. I'll be giving you one more homework, and also I'll probably give you an extra bonus round as well for you to work. Okay, so so today's lecture we're going to get into what is exactly validation in relationship. Yes, yes, Marcus. Marcus, you said something. Hello.
Sorry, my finger pressed the unmute button on accident.
Okay, no problem. Please interrupt anytime you feel confused. I appreciate it. All right. We're also going to get into ISO 15288, talk about transition and validation. One of the exercises I'm going to get you guys to work on is MOSs, which is kind of the measure of suitability. We've talked about measure of effectiveness. Suitability is a different type of animal. We're going to look at that. And also, we'll end it with talking about T&E within the DoD domain. So as you remember, we went into implementation. We went ahead and assembled and put together the system as a whole. And we looked back at the detailed requirements for that system that we built. Now we're going to go ahead and take that system, put it in its operational environment, and actually start thinking about the actual validation of the system in its environment. So that's where we actually confirm it can actually do the mission for the system that we've built. So if you look at 15288, it has definitions for all these processes. Validation is no different. Basically, what it's doing is trying to get you to find objective evidence that you can use to ensure that it does, the system is used, complies with whatever requirements the stakeholders came up with. And you usually look at it in relationship to the operational environment it was in. So did you, was the right system built for the mission that you're going to do? So as a matter of fact, the the Guide to the System Engineering Body of Knowledge, or SEBOK, kind of says the same thing. It's the confirmation through provision of objective evidence that the requirements for a specific intended use or application has been filled. Did you build the right thing? So what do you validate? Well, there's actually several things, and we'll get into this. And hopefully when I open up the mics, and we'll do a little whiteboarding, but you can validate stakeholder requirements, the design, the system. All it takes is for you to put it in front of your customer, your stakeholders, and make sure that they agree either with the requirement or the design or the system itself. So any element, system engineering element or artifact, can be validated when you have a very specific reference for your comparison that you will work. So we'll get into that when we do a little bit of whiteboard. We'll think about that. So really, when you think about verification, which was last week, we actually talked about the purpose was to try to find fault with the system you built. And you're trying to figure out the truth. You know, is it yes or no? Does this thing work in accordance to the requirements you levied on it? So it's very detailed, very local. And your vision's more like glass block. How's it running? Is it running the way we said it would run? And usually a very fine-tooth comb. And really, we're just trying to figure out, did we do it right? Did we build this correctly according to the system design? So we usually verify it first. Yes, the system's built in accordance to the requirements we wrote for it. And then we install it, put it in its environment, and we do this thing called validation. And that's where we try to actually get more confidence in what we acquired. And we're very judgmental about the value that this system is coming into play. It's much more subjective because the system itself has to be accordance to the mission that's trying to be accomplished. So it's very global in context, very black box. Your system runs as a black box. It does its thing, and you see how it works within the mission. So that's why the whole point of view is not so much done right as does it do the correct thing that it's supposed to do for the mission. So it's very stakeholder requirement capable, and usually it's after verification you do validation. All right. Different points of view. Validations are usually system validation is ratified by the stakeholder. Whoever benefits from the system usually gets involved, and they are actually the end users, or your stakeholders or your users are actually working the system and making sure it works. So a lot of times you put validation into the acceptance criteria. Your program office or your customer won't buy it until they confirm or accept the system that it does do its mission. The test evaluation and master plan we talked about last week is this whole triune of the program office, the customer or operator, and then the operational test authority, which actually finds that, does the validation to ensure that what the program office bought is indeed helpful to the operators. So you are looking at this as the operator point of view. They are a fundamental part of the system. They need to be trained and ready to use the system when it goes into your validation mode. A lot of times you would use the concept of operations. We talked about in the past. 661 talks about it when you're there. The whole idea of what is your concept of how this system should operate within the mission it was designed for. Actually taking those concepts and actually running the system through those concepts, or the ConOps, is a great way to do a validation. And don't forget, this should be installed in a operational environment so that you're able to make it work. Now, there are enabling systems that may be required and make sure to make this work. Sometimes you're in an operational environment, but the actual what you're looking for is not available to you, so you may have to simulate it. So simulation, operational environment, from a simulation standpoint, could be something that you need to develop to make it work. But make sure, even if you don't find or you cannot conduct in the operational environment, find a place that's close to that so you can be sure it works. All right, any questions so far? And anybody have any stories about things they've done from validation standpoint? I had to go to the desert to test our equipment because it was going to go overseas, but we didn't want to test it over there. So we usually wind up trying to find locales in the United States that were closely resembles where we were going to deploy our system. So a lot of test facilities out there that can help you do that. All right. No questions. We'll move on. By the way, can you guys tell me when you see my screen, is my thing flipped correctly? Can you actually see SYST663?
Are you talking about your background?
Yeah.
Yeah. Yep.
Yeah, it's good. Okay, it's funny because it's flipped for me, but it's good for you. That's so weird. So it's hard for me to talk sometimes, but okay. All right. Okay, let's think about 15288 in terms of the way we look at two processes. Remember, last week we talked about the verification process. What feeds that, once you have a verified system, you need to transition it to the customer or to the operational environment. When I was working for the Navy, I transitioned it to a ship, and of course we had to do a ship check, make sure it can go there. We had to figure out the actual power, space, and cooling, and things like that. So that may be something you need to work with when you're trying to install a verified system. But even though it may go fast within a week or two, it still should be highly planned in order so that you won't be surprised. Oh, we don't have a plug to make that work or something like that. So be sure all the activities are thought through and that you're ready for them. So if you think about the IPO or input process output chart, the inputs are the actual verified system. As you see here, you prepare for this transition and then perform it and manage whatever the results. The output, the main thing would be the actual installed system. And I have in here a write-up of each of the inputs as well as the outputs here. But from a activity standpoint, you plan for it. So there are aspects of your inputs that help you with that planning, especially the concepts or the VR, the final RVTM. But you actually make sure you're planning and got your installation procedures written up. Any enabling systems that you need, you make sure you buy them and they're available to you. And then you perform the transition, install the system. If users need to be trained, you need to get them ready for it as well. And then once you have it installed, you may do one final confirmation check. And then once it's installed, you take whatever information you have with whatever anomalies perhaps that you had when you installed it. All that is maintained and recordized or put in record form so that it could be used for later processes. All right. So, and don't forget, a lot of times the quality assurance, operation management can help you through this, especially for documentation. And a lot of times this is the acceptance. You put this in, you do some acceptance activities perhaps even run it through its ConOp, and then you can have this thing accepted. So that verification, validation usually is on top of this once it's installed. So validation from a 15288 standpoint is just making sure you built the right system and that you're actually going to make it go through its mission or business objectives and make sure it meets those objectives. So you're just trying to make sure that all the stakeholders are satisfied with what's being written here. But keep in mind, validation is something that you can work through the entire life cycle. As a matter of fact, we have some examples here for you after we're done here. But basically, again, the input and the outputs here, it's really your installed system is the main thing. You perform your validation and management, and you have a validated system at the end. So your inputs, write them out here, things that kind of support your planning aspect. You're trying to get the strategy together, figure out your constraints, and making sure you have any enabling systems in place. And then you perform your validation, actually your procedures, and conduct your validation and record it. And so then you manage that records. So your requirements, verification, traceability matrix will be updated with that new information. Any anomalies will be documented, and they will go forward to the next processes, which is normally the operations. And we'll cover that next week. And so as you can see, some of these outputs are actually helping you in the planning phase, but the actual validated system is the main thing, as well as the report. Again, we talked about the ConOps being a great way to exercise all the operational modes and demonstrating that the system can run throughout its whole operating regime. Drafting up a validation plan as soon as you know the ConOps. And the reason you do that, I know we had to do that from the Navy standpoint, is I had to get ships scheduled, and usually it takes 2 years to get a ship where you need it to be. So we needed to make sure we understood what kind of methods we're using and what kind of resources were necessary. I mean, if we need a simulator, you can't just say, oh, we're going to do a demonstration for our validation in 2 weeks. Let's get that simulation done. It could take 2 years just to write the simulation. So make sure you plan all this way ahead of time. As soon as you start getting your concept together and you start thinking about your test and evaluation master plan at your point. There's a lot of things you have to deal with when it comes to validation, especially when it comes to perhaps the system dynamics or integrity and where it stands within the limits of what you're designing. So sometimes you actually have to ensure that that is available to you, especially if you're looking at things like suitability or survivability or the fact it can be refurbished. What does that require? And don't forget you may have some interoperating systems that you need to make sure they're on hand, and try to involve all your stakeholders so they can see what exactly is happening as you go into, especially your users and operators. So one thing I want to do is go into this idea of a notion of a validation action. And we covered this the last time. So let me just pull this up real quick and get a little closer for you. You guys can open your mouth. This is actually verification, but I'm going to show you how we kind of tack on validation on top of this. So if you were to actually do a requirement up here as something you wanted to validate, you first need to verify it and make sure that it meets what kind of requirement. Can you guys tell me what kind of requirement I'm always looking for when it comes to requirements?
Stakeholder?
No, that's it. That's a good point. But remember, when you verify something, you're testing it against a standard, some kind of
Standard requirement.
yeah. Is it a good requirement, right? Was it written in a way that's verifiable, measurable, right? Achievable, things like that. See that? So our verification action will actually give us our results. So we could actually get down here and let me get a pen, and we could have a yes. You guys good? Okay. I wonder why it's doing that. That's weird. But oh, sorry. Let me delete that. Let me go back here. But when it comes to the actual now, let's say we want to validate this thing, right? And how do I put this backwards? I think there's a way to push it back in there. All right, I'll figure that out. So let's say the requirement, right, has been looked at. You did this action, you got your absolve, and you've got this yes happening, right? What's happening down? What's happening down here? Right? So this is where validation actually is occurring, all right? Can you see where even though you may say yes, what will happen if your stakeholders find it unacceptable? Have you guys ever had that issue? Guys, anybody there? Okay, nobody.
Yeah, I'm here, but I haven't had that issue.
Okay, well, which is good. I agree. Normally, when you are verify something and it's good, well, from a requirement standpoint, it's important to get this validation because you could have the best requirement ever, but if the customer doesn't agree with it, then it's unacceptable, and you have to start rewriting it and getting it correct as you're doing that. So it's important to do that. Now, let me erase that. I think I can do this. Oh, darn. All right, so there we go. Erase it up here. All right, let me do this real quick. Let's talk about what this is a requirement that we're dealing with. Sorry, I really thought this thing would move. Let me try to, there we go. Let's replace this requirement with something else, with the system itself. We're trying to do the system. What's my reference for the system that I'm going to use in order to do verification as well as validation? Anybody have a clue? We talked about it, but I want to see if you guys remember. Come on, interaction. Let's get some interaction here. Wow, you guys just love listening to me. Go ahead, Rohit. Talk, please. Did you want to talk? Go ahead. No?
No.
Come on, guys. I'll wait until you guys figure it out. Look at your old notes. Come on, Jordan.
I was asking, could you repeat the question? I didn't really.
Yes, if I am taking a system and I'm going through verification or validation, what is my reference to figure out if it meets this conform in order to get that conformance? What is my reference over here?
Oh.
Right?
Besides standards?
It is not standards, right? Well, it depends on what kind of. It's the system. So if you're testing verifying a system, what are you verifying it against?
Criteria?
Right, which is from where?
Oh.
Come on, anybody else? You know, this is what I really feel bad because this is probably one of the main things you should take away from my course. So how you verify a system or validate it.
Is it the requirement?
There you go. Now, was that hard? Now, why was that hard to figure out?
Sorry, I don't know. I guess I was overthinking it. I was like, it can't be that simple.
Yes, it is. And really, I don't want you ever to think I'm trying to stump you guys. It's not the point here, right? I'm just trying to get you to think through what I've already taught you. All right. So I know I'm going on and on and on and on, and it can get very sleepy. But let's try to pay attention. So the system is verified or validated against the requirement, right? You have an expected result, you compare it to your obtained result, and you can conform. Okay, but what is that extra step you need to do in order to get it validated? Remember, this helps me know I verify that the system is being built. How do I know through validation what is the action I do in order to ensure that the mission confirms the mission? What do I use down here? What am I looking at?
Testing.
No. Remember, it's validation.
You can get
That's
stakeholder feedback.
Stakeholder feedback. Thank you. Who said that?
Marcus did.
Marcus, thank you. So all you're doing is you bring it to the stakeholder. That's why you get so many stakeholders involved. And they have to decide if it's acceptable or not. And that's why you can wind up with something that's a yes and wind up not being able to install it because the customer doesn't agree to it. Now, if you have this happen, what fell down in your development process? What kind of screwed up? Where did you screw up?
In
Not-
the requirements, probably.
You screwed up on the requirements. That's right. Okay. And if your requirements are wrong, right, you went down here, you tested the system against the requirements, and it was good, but your customer said no, then you didn't elicit the requirements correctly. So that's why up front, getting those requirements understood and actually validated through your customer is an important aspect to this as we're working. All right. I don't want to bore you guys too much, but that's one of the reasons this is a very important, this validation action and what you are looking for in order to try to make sure the system is ready to be deployed. All right. All right, and here are some examples I gave you. The requirement up here, engineering artifacts, the architecture. You can actually verify the architecture meets certain heuristics, but you may want to get that architecture in front of the customer and see if they agree with it. And of course, the system itself. All right. And here are some techniques we talked about. It turns out the techniques are the same. I mean, verification, validation, both can use testing, analysis, validation, analysis, and testing, and things like that, or in inspection. Usually validation turns into a demonstration because you have the system as a whole, and you can demonstrate it a lot better. Verification, you have a lot of probes, and you're trying to get more information, so the testing may be more involved as you're doing it. There are different types of ways to go about doing validation. You are trying to validate the entire system. That's an important aspect of this, but of course your mission may be multi-leveled, and so you're actually doing some actions where you culminate to where the entire system has gone through its operational scenario. And of course, validation becomes important at a decision gate. If you want to continue to build these things or deploy them, you have to have results available to the decision makers. Acceptance testing is usually very helpful, especially after transition. You run through validation in order to do your acceptance. Certification is another thing that usually get outside authorities. If you're building something that requires, let's say, EMP protection, you may have to give it to some EMP specialists who kind of hit it, and then they confirm, yes, an outside authority would agree with you at that point. Readiness for use. We have something called the authority to operate. So there's an aspect of you validating the system is ready, but other decision makers have to come in and say, yes, you can go ahead and deploy it and use it. Qualification, usually within an environment with a lot of interfaces, you have to qualify that you're not going to hurt these other systems as you're working through. And that's where you get this validation, just like we did with verification. You do it level by level. You can validate even an element that it is indeed validated, it can be used within the greater system, and then you build up the subsystem till you get to the larger system. All right, any questions? All right, we're going fast here. Please stop me if I go too fast, or if anything is confusing as we're going in. One of the things I want to talk to you about is technical measures. MOE, we've talked about. That's the measures of effectiveness. Another aspect of a system and being able to meet its mission is measures of suitability. We'll get into that. But measures of performance, that's from a system standpoint, and then technical performance measures from an element standpoint. And of course, we're system engineers are responsible for when that transition of the capabilities in the operational environment, that these measures are done so that we know how the system will operate when it actually gets deployed. So validation criteria, one of the things is this measure of effectiveness. How well does the system work its within the mission? We talked about this in the past. There are sometimes critical operating issues that a operational test and a T&E outfit, like they would actually go in and actually look at these operational issues and make sure that they are satisfied so that when the system gets deployed, you won't be surprised. So you can see where usually this is phrased like a question. So you say, hey, will the system detect the threat in the combat area in adequate range to allow successful engagement? In other words, operational effectiveness. Is it doing its mission? Now, the other question you may have is, how safe is this thing when it's actually in operation? And of course, you're looking at the safety of the operators, and that is an operational suitability. There are other suitability components we'll talk about, and I actually want you guys to think about how you would bring suitability into the pomegranate function that you're responsible for. All right, so operational assessment, normally they look at both, not only how well it operates from a actual effectiveness, but also from a suitability standpoint. So, and normally they have a list, pretty long list of configuration of these critical operational issues, and they have to be satisfied in order for the system to be approved. These are some definitions. I've already covered them, but I put them in a chart for you. All right. So effectiveness is the ability of the system to accomplish its mission. Suitability is the degree at which the system can actually be sustained and in the field, and it's available when it needs to be. It's safe, it's reliable. A lot of these, if you read them, there are a lot of ilities that are involved, if you ever heard of that. like supportability, habitability, maintainability, things like that. But the environment, the impact, actually I have a list here, but this shows you how you look at operational effectiveness in terms of its mission being accomplished, whereas operational suitability is the system available? Is it reliable when it does its job? Is it supportable? So those are the things you look for. So this shows you some examples of how you could write critical operating issues and how that could turn into this measure of effectiveness. And then you could add other measures of effectiveness in light of this critical operating issue. Suitability, that would be something like reliability, maintainability, availability. This is all in one, but they're just saying how the RAM, the reliability, availability, maintainability, is this aircraft suitable to fulfill its mission? And then you would have some actual measures of suitability. What are the mean times between failures? What is its maintainability, its availability, and things like that. Here's a real world example, shows you the MOEs going down to a lower level, the MOPs, and then of course they would go lower still. All right, let's get an example here. I need you guys to get ready to unmute. I'll wait for you while you try to do the calculations. Let's see if you guys can figure out geez, I just showed them. Shoot. Okay, I want to show you these, but I want you guys to think about the MOSs. So what would be some MOEs? Be something like, you know, how fast can it reproduce color copies, right? Or how expensive is the ink and the paper and everything to make a copy? Or how much power is being used per hour while your system is being used? And what about the heat being distributed? So these are all measures of effectiveness. It's how well can it work? What would be some MOSs? Not trying to trick you. We already talked about 3 or 4 of them, so you can just yell them out. You guys there? This is where I really wish we were together. I could point at you. You guys all fall asleep? Ha! I'm just talk. I have that kind of effect on people. All right. Anybody? What be for a copier? What would be a good measure of suitability? Anybody? Wow. I feel bad. I'm not teaching well at all. All right, let's look at a few back here. What were some suitability here? What were some things? Just read them off the slide. It's fine.
Mean time between failure.
Right. Like how many times does this thing jam? An hour, right? And what's another one you see there? Looks like you're the only one awake, Jordan. Sorry.
Time to repair. So yeah, you could really just apply these to the printer. Any mean time before or to repair or whatever, that would assess the suitability of the printer.
Yes, as well as and that really is kind of something from a reliability standpoint or maintainability. And there's actually ways to actually work that type of data out. So, the other thing that make it suitable, you may not have thought of, is the noise level. All right. So it's great to have this thing working, but it's in an office environment. You can't have it too loud. Is it working? Because if it is too loud, you have to have it in a different room that's kind of isolated from everybody else. So that may be something that would impact your suitability. And of course, if your BTUs are raising the heat of your system, of your room, that could be a suitability issue as you're working that. There are other suitabilities besides availability, compatibility. Like let's say you have a really nice copier, but it can only take A4 sheets. You're like, what about letter heads? So compatibility with standard aspects of wherever it's being used. Transportability, how hard is it to actually get the copier to the field? Interoperability with perhaps other systems that are within your office environment, reliability, usage rates, maintainability, safety, human factors, logistical support, documentation, training, and other things. A lot of this. So I want you to look at this list when you do your exercise and think, well, what can I put into for my function that we're kind of doing, okay? So I go through each one of these for you to look at later as we go through this. I want to get you guys go ahead and do your exercise so that we can kind of wrap up rather quickly if we can. All right? So I'll let you read all those. Go back and review them as you do your team exercise. Basically, take your function, write a critical operational issue question, and identify the measure of suitability to that question. Make sure it's a question that's related to suitability, not to effectiveness. And don't forget, looking at all these, you have some kind of threshold involved or some kind of criteria that would make it work. All right. So I want you to think about those as well. I do have a list down here of what we just went over for you to use, but talk about each one and think about which one. Really, I'd like you just to do one, like pick one, like transportability or something, and then identify a question that's related to it and identify the threshold and criteria for it. All right? I'm going to give you guys 15, 20 minutes, so about 5:35. Let's meet up in here. You guys go ahead and go into your teams and pull up your. You should be able to pull up. Should be able to pull up your the only file for this class, which is the exercise here. So just go ahead, pull it up, and start working on your exercise. And they've already started it. Good job. All right, guys, get to work. We'll see you in about 20 minutes. All right. Hi, is everybody back? We don't have Jordan and his group. Let's see. Okay, let's get these guys done. All right, guys, let's get the what team would do, let's do team 2. See what they have. All right, you ready? Let's
Yeah.
one more exercise, guys, after this. All right. This thing. So which function were you again?
We read the voice recognition. You're not sharing the screen.
I'm trying to get it to come up. It's not coming up for some reason. Oh, I'm not sharing the screen. Thank you.
Yeah.
Thank you very much. All right, there we go. There we go. All right, can you see the measures of
Yeah.
yeah. All right. Thank you for that. Yes, very simple one for voice translator. What are you worried about?
Yeah, so our question was that will the noise from the crowded area interfere with the voice translator?
Very
So, yeah. And I mean, if I want to elaborate that question, it would be like if I'm in a crowded area with the voice I'm speaking, if someone else is speaking something else, would that be a problem or not?
Yes.
So our MOS is reliability.
Well,
and-
not necessarily, right? So reliability is a very specific scenario where the thing is working in accordance to its suitability. What is it? Maintainability and that it's working. So reliability doesn't quite fit in this.
Yeah.
So the MOS is more like, well, noise suppression, right? Is that what you're looking at, or noise reduction, or what do you call it when you cancellation?
Yeah, noise cancellation.
That's it. Yeah, noise canceling ability. So that would be your capability that you're looking at. And you're right, that's a good threshold that you're looking at.
Yeah, 15 dB.
Yeah. All right. So that was going, and I feel bad. I didn't really explain what reliability is. I wonder if I'm going to do that after this. Do you guys know? All right, let me see if there it is, strike through. Good. No, that's perfect, guys. Perfect. All right. All right, let's get team 3 up here. Who's going to talk to this?
It's gonna be me.
All right. So
Yeah, so our COI.
okay, let me pull this up. See if I can. I'm just going to mess your whole thing up. Nope, can't do it. Can I do it? I just have to get rid of these things. And you're safe. So what's your COI?
Yeah, it's so is this coffee produced by the pomegranate device safe to handle with any standard mugs? So the safeties are MOS, measure
Yeah.
of suitability.
That's
So we came with four actually. The coffee poured in mug shall never pass the threshold temperature of 200 degrees. So that's a temperature threshold. The second is the time. The coffee pouring process in mug shall not take longer than 5 seconds. So that's a safety measure. Like
Mm-hmm.
one should not have to handle it for a long time.
Oh, I
Then
see.
the third is the coffee pouring rate shall not increase 8 milliliter per second, just to avoid splattering the hot coffee over the hand
I
of
like that.
the customer.
Yeah.
Yeah, And then I was not sure of the fourth one, but I just wrote it. The coffee device must never leak any extra coffee droplet after its use. Like it's a mobile device, right? So it must not leak any droplets after its use. But I was not able to frame the MOS right.
Yeah, no, I got you. Yeah, it's more like you don't want the droplets to be hot, right?
Yeah.
Uh,
Yeah, and I couldn't like set any threshold requirement, like any threshold statement for that.
What if we did what we did up here, 200 degrees Fahrenheit? We did the same thing. Yeah, that might work.
But it,
What do you think?
and we can add factor of milliliters. Like it should not
Oh,
leak any more than 0.01 milliliter.
0.01 milliliters. Good. I like it.
Yeah.
No, that's good. No, that's good. Too good. Excellent. That was good one on safety. Now, guys, I want you to think about this because your individual homeworks, you'll be doing the same thing. So that's why I want you guys to kind of think through these. Now, how about team 4? Then we'll get in through this. All right. If I can, darn. Really want to get rid of these things. All right, go ahead. Team 4. Yeah,
Hello?
somebody may be on, but I can't hear you.
Yeah, I'm here.
All right.
So our question was, will the pomegranate razor? We had the razor function. And
Yes.
ours was, will the razor be able to cut different grades of hair within a tenth of an inch or arbitrary amount of the desired length in an operational environment? So we wanted to do availability, kind of maintainability at the same time, mean time between failures, and the mean time to repair of the razor's blades, because we were
Mm.
assuming that it can't cut after a certain dullness of the blade. Now our threshold was that we wanted to last for more than 1,000 shaves.
Yeah.
Which would get you, well, if you shave, once a day with your phone, if that's what you wanted to do, it'll get you around 3 years. And then the criteria is the user hair can't be longer than 5 inches. It's not for a full haircut. It's just for a quick shave. Has to be used in environments that aren't that hot, so the metal doesn't dull out or anything, and it has to be used in dry climates. We don't want it cutting wet hair and stuff like that.
So can you see where your question is more like a MOE, right? So
Yeah.
you're more effective in that question. So you want to make sure your question is related to suitability. So you asked about availability. It's not unheard of to ask the question, will the pomegranate function be available? Right.
Okay.
Right. So that would make it suitable, right? And then you would have to go, well, what does it mean to make it available? Well, it can't be down for repair. So your mean time between repair is part of that availability thing that you would look at. So,
Okay.
and I think the criteria would have to actually relate to that you're still talking effectiveness here, whereas the criteria for availability is more in terms of repairs. Repair. Well, you have a threshold, but you were looking again at the effectiveness repair every 1,000 hours or something, right? Whatever so you have to have an aspect of the mean time between repair, like every 1,000 hours. How long does it take to repair? Does it take an hour or 3 hours? So that's another criteria that would kind of flow into your availability. Does that make sense? So the reason I
Yep.
want you to
Yeah, I
kind of
get it.
get that, yeah, is that I want to make sure your homeworks that you guys indeed don't give me of effectiveness, but more of a suitability question. All right. So good, but still, I mean, you kind of got the gist of it. So that was good, guys. All right. All right. Let's finish this up. What I want to do is give you some examples from DoD and kind of get into some DoD aspect of T&E. I'm not going to go into deep cover on this thing. I'm just going to do it real high level and skim over it. I'll let you read the things, but I think I can get you guys out of here rather quickly and have you guys start the homework. And I want to talk about the homework a little bit as we're doing this. So this is an old technical measure tree where they looked at what they called MOOs, or measures of outcome, which were related to measures of effectiveness. And then you would actually look at the system level for the MOP and TPM at the element level. But notice that when it comes to MOSs, you would be like my reliability, my system level, what's my MTBF at the system level, and then at the component level. And those would relate to the reliability at the mission level. All right, so you need to actually think about what the system needs when you think about the key performance measures and parameters for your operational test and evaluation for DoD. So you need to make sure that whatever your test and evaluation strategy is for DoD, that it's well within the acquisition strategy. In other words, there's cost for the contractor to do their developmental T&E, and there's a cost for the operational T&E when you get your operational force involved. I mean, your independent test authority. And of course, make sure you have an initial operational test and evaluation if needed. But as you can see by all the documentation, be it system specs, your capability documents, your acquisition strategies, and things like that, your management approach, you still have these tests and evaluation documentation that's fairly important. And they have to be written in context with all the other documents that are made. Notice the difference between the DT&E, which is contractor-based, controlled by the program manager, whereas IOT&E or OT&E is controlled by the independent agency who's making sure the system is ready, not only effective, in other words, it can do what you said it would do, but it's suitable. In other words, that it's maintainable, it's available when needed, it's reliable, and other abilities. This just shows you from a test and evaluation master plan, you start with a very beginning draft at the very beginning when you even think about the system, and then you build on that draft as you go along. So you can see the temp is at the very beginning before milestone B. Afterwards, you update it. And then from there, well, let's talk about what the test and evaluation plan is. Usually, from a template standpoint, you have the system introduction, the actual summary, outline of your developmental testing, and then the outline of your operational testing. So there are times in your test and evaluation plan you may actually combine the two if necessary. Because one of the things that's important about your test and evaluation plan is understanding the resources you need to have in place. If you're doing a weapon system that fires missiles, you need missiles in order to make sure it works. And you need probably something to shoot at. So all those type of test articles have to be thought through as you're doing it. your temp kind of relates your schedule, your test management strategy, and your resources against your actual critical operating issues, your technical parameters, and other values and strategies necessary to make the temp useful. All right, so you have your evaluation of the actual system in itself, but its interoperability, logistics, and other things, training, the way it interacts with the organization, all have to be taken into account as you're working this. So the operational test and evaluation is usually at the end, but again, notice down here, my operational test and evaluation is thought about at the very beginning, and it improves, and then eventually you actually work it through. All right, we'll let you listen to this separately. Basically, it's a nice NPR section that talks about how the Army actually deployed these weapon systems into the field of battle in order to do the operational test. So they actually had soldiers in there doing the work. It's quite a interesting aspect of making it work. All right, let's talk about the TRR, where we're trying to get ready for the test and evaluation aspects. And so supporting the TRR will support this aspect. A lot of aspects about the TRR where we're looking for test plans that are done, resources have been identified or available, that your system or subsystem or your components are all been tested, you're sure that they're ready to go, and then you think about the risk involved for your leadership. All that is discussed during the TRR. Now, of course, when we do our TRR for you guys, for me, you're just doing kind of a piece of it. So that's why I only want you to do a portion of the test evaluation plan, and also just a few of the artifacts in order to show that you kind of understand what the TRR is and what it's about. So these are the exit questions that we have. And basically what I want you to do is look at the VCRM, provide a VCRM for me. One of the things that I want to talk to you about, let's work this up. Did you guys see my, there we go. Did you guys see the announcement I made? I actually am showing or having you guys look at some of the VCRMs that were done by previous classes and teams, basically looking at the requirement, the verification method. Some of them kind of followed my thing where you actually look at the requirement and then you look at your verification objective and your pass-fail criteria. This is a very effective way to do it. Others just kind of looked at each verification class and described what test procedure would be brought up against that element as we're doing it. The other one, notices again, it's a requirement describing the verification requirement and what it verifies and what method you're using. This is an interesting one. You put your verification requirement in and you link it to all the requirements that it would verify. And there's a cross-reference matrix here as well. This actually goes down like this, where you actually have your objective, your method, your environment, success criteria, and they went on for several pages like that. So the reason I'm showing you all this is there's no one way to do it. I want you to think about it. What's the best way to get this across? So think about, and I really want you to try, what you should do, get your verification into core. And if you look at core enough, you may be able to see a nice table that will actually give you the VCRM. You don't have to build one from scratch. You can take it straight from core. So look into that and see if you can do it. If you can't, and it's too much of a struggle, just go ahead and put it in an Excel spreadsheet. That's fine. But do try to make sure core has the information in it as well. Also, don't forget that you should identify your technical performance measures when it comes to your configuration item. What are you actually looking at in order to make sure the item is being built correctly, and your verification requirements for that item, your test plans, and your test schedule for that. All right. And what I kind of do now is talk about how operational T&E is actually, well, first your developmental T&E where you're combining it with operational. There are some verification validation links that are on, but operational testing and evaluation goes beyond just the actual effectiveness of the performance. They want to know, is it suitable as well as survivable? Those are also important. This goes into, you know, when you look at the mission element versus the system element, and then what kind of evaluation or testing is done between those elements, and it kind of shows how they link to each other. All right, and of course, test reports are very important. They disseminate the information of how well the validation went forth, and it's a good record of saying, yes, we passed and executed the test, and here are the results. There are some pitfalls you need to worry about, especially if your validation is kind of pushed up near the end of the project. It's a lot of times you want to cut it short. That's a common mistake. You don't want to have that done. Don't forget it's validation. It's not just testing, so that there are times you want to consider analysis, especially for some of these entities. They're very hard to figure out. Analysis is probably one of the key aspects of this. And of course, funding, as it runs out, all of a sudden your validation can't be done, and that's a real that can really stop you from deploying. So don't let the funding be burnt up by other aspects. Protect your validation funding. Start your validation plan early. Make sure the requirements are written up and looked at. There's a cost for every requirement, including validation requirements. Document your actions and involve the users to help you with your validation, and make sure that those stakeholders are indeed involved. All right. Now, I'm sure you guys are tired, but I will go ahead if you have any questions. I'm listening. If you have anything. All right. Well, we finished by 6. Good. I'm going to have you guys leave early today. I do want to remind you, you only have a few more weeks until the TRR, so make sure you're getting together as a team to do that. We do have one more homework. You should have pulled up. Let me pull this up. You should have. You have one more homework due. Basically, I just want you to do exactly what we did here, but individually. Write a critical operational issue question. Identify a MOS. Remember, the question should be related to the MOS, and identify whatever threshold you can. And you can look up reliability, availability, and things like that to make sure you have the right information. Okay, and I give you some hints down here of what to look for. All right, so that should be very straightforward. You can use the same technique that we used for the exercise. Also, I'm going to give you one more thing that you can look at. Let me see if I have it up. Test run not on. Okay. All right, I might talk to you about it next week. Yeah, we'll talk about it next week. It really, it's a it's a real short, easy to do. It's optional, but it can give you an extra 100 points as we go in there. And I don't, for some reason, I don't see it available. So I just got to find out where I put it. But I'll make that available to you so that you guys can kind of prepare for that as well. Next week, we'll be talking about transition, the transition one. Let's go back to this. We'll be talking about transition and operations. And then when the TRR occurs, your homework 5 should be available. And I'll have that extra homework for you as well. You'll have that done. So those will be, you'll be able to wrap up that for your grades. And then the last thing you have to do is your team assessment. All right. And of course, the final exam as well. So we're getting very close to the end here. I think you'll find that we'll be able to skid into home plate here, and all of you will hit a home run, I'm sure. So I'll hang here until we're done in case you have any other questions or you want to talk about the homework or things like that. All right. So other than that, you guys can go. All right. So you don't have to hang. All right. We'll see you guys next week. All right. See you.
Thanks.
Thanks,
Thank you,
guys.
sir. Thank you.
No problem. We'll see you later. Bye-bye.
Thank you.
Thank you.